Hello guys, my name is Kazim Oluwashina Amawo. Welcome to my tutorial. In this tutorial, I want to talk about some of the things I consider when it comes to column placement. That is to say, how I choose to orientate my column in a structural layout GA and the reasons why I choose whichever orientation I go for. So without wasting much of our time, a brief introduction. We all know that as structural engineers, when we receive blueprints from architect, we are meant to design the structure in order to stand the test of time. So one of the basic things that we do is structural general arrangement. As we all know, the manner in which we arrange our beams, columns, slabs, and what have you. Of all these elements, we choose to orientate our columns based on different reasons depending on our experience, education, and all. But as engineers, we don't just do these things because in engineering, everything is based on principles. So I want to share with us how I choose to orientate columns and the reasons why I choose a particular type of orientation for a particular type of scenario. So now let's get into it. Let's assume we have a plan like this. Let's say this case 1. So I have this plan and I want to insert my columns. I want to use a column of 225 by 450. How will I orientate these columns? Will I orientate it this way or will I orientate it this way? So let's say the slab has an out to out measurement here of 10 meters. So now which orientation will I choose? Will I go for the red orientation or will I go for the blue orientation? Let's find out. Let's cut a section through both orientation types. Let's talk about section XX first. Now let's see for section YY. So now that we are here, what I want us to check is the fact that, what I want us to realize is the fact that this side, this section YY, for the fact that we have chosen this orientation, the center to center distance between the two columns is now 9.55 meters. But if we look at section XX, the center to center distance is 9.775 meters. What this is telling us in essence is that there is more stiffness in section YY as compared to what? Section XX. So definitely, if you load these two members with the same kind of loading, there will be lesser bending moment generated in this place as compared to this place. So you can see why, in my opinion, I would go for this orientation, this. Simply because if I'm given two options, when one option is giving me lesser bending moment as compared to the other option, what is telling me is that I will be needing lesser reinforcement here in the YY as compared to how I'll be needing reinforcement in the XX. Mind you, you may be thinking, it's negligible. 9.775 minus 9.55. That's just around 0.225. Yes, it is negligible because we are working with this little example. Assuming you are working on a very large project and you're having members upon members upon members that you are designing, and you are able to save this little percent all across the whole project. Imagine the number of reinforcements you save. And remember, in engineering, we are always designing for what? Safety, number one, and what? Cost. We are always trying to balance between these two things. So this is one of the reasons that I usually consider, and I don't want this video to be longer than this. I hope you enjoyed it. In subsequent videos, I'll talk about more cases. Thank you very much for sticking with me. Please like, subscribe to this channel, and drop your comments if you have any question. I'll be coming up with subsequent videos to continue this particular discussion. Thank you very much. Bye.